Hey, good morning, sixth graders. Today we're going to be going over 5-8. We did this in class already, but this was a really difficult lesson, and so I'm glad that we're going over it again. If you remember in your, this is in your workbook on page 195. So go ahead and pause this video or take a second to open up your notebook to page 195. So we have 7 examples here. And in class, we discussed these examples and we talked about, so example number 1, King said, if I forget what 7 times 8 is, I can think of 5 8s plus 2 8s, which is 40 plus 16 is 56. And we talked about how that was correct and how there was just different ways that we could write or rearrange these numbers. Same for example number 2, except for with fractions. I see there that there are a total of 7 ninths, or 7 groups of 1/9, right? 1, 2, 3, 4, 5, 6, 7. And so when we circled these, so this first group, we'll call this the green group. That was 5 ninths. There are 5 groups of 9 there. In the second one, the blue group, there were 2 ninths, or 2 groups of 9, right? Okay, so that is another example of the distributive property. Example number 3 is 5 boxes with C books in each box plus 2 boxes with C books in each box. That makes 5 plus 2 or 7 boxes with C books in each box. So that's another example. And what that looks like is right next to it in example 4. That's a drawn out version of, we have 1, 2, 3, 4, 5 boxes with C in each side, or in each box, plus 2 more boxes with an unknown value similar. So we have 5C plus 2C, or 5 plus 2 with C in each side. 5 plus 2 times C. So we did all of those. I'm going to skip 5 and 6 because we talked about those in class. So I'm just going to X those out, and they're very similar to examples 3 and 4. What I want to do is I want to skip to number 7. And the reason is this looks very similar to what we've done with geometry, and it looks very similar to what we've done with multiplication in 4th grade. If you remember back to how we multiplied using these boxes, right? Place value 40 plus 4 times 60 plus 1, and then we meet. Okay, you get the point. So as Mariah said, the area of the big rectangle is the sum of the areas of the smaller rectangles. Dave said the area of the big rectangle is its base times height. Mariah said that means AC plus BC is equal to A plus B times C. And in class, we worked that out and we saw that that was actually true. And so on here, let's make this nice and big, because I'm going to do some writing, and I need you to, you probably have this already written in your math journal, and that's okay. It's so that's a lot of writing, and so I'm not going to write all of it. I am going to read what we wrote together, so please listen carefully. AC plus BC equals A plus B times C, because the area of the blue rectangle is C times A, and the area of the pink rectangle is C times B. Added together to get the whole shape is C times A plus C times B, which is the same as adding A and B and then multiplying by C. And that's correct. If I do, and I'm just going to reiterate this in this box with a green pen. C, C times A, that's C times A, right? and then C times B is the same thing, adding these together, as adding A and B together and then multiplying by C. Right? Those are the same things. So let's keep that in mind as we move forward. Okay, page 196. Here's your vocabulary word, distributive property. So the distributive property gives us two opposite ways to transform expressions. And if you remember in science, we talked about transform. It just means to rearrange in a different way into equivalent expressions. We can distribute a factor to the terms of a sum or difference. 5 plus 2 times C is equal to 5C plus 2C, but C is distributed to both the 5 and the 2. We can pull out a common factor from the terms of a sum or a difference. Okay, so we can go forwards or backwards is what it's saying to you. Okay, so we did these in class, and we decided to draw arrows, that we were going to draw arrows, right? It says in the directions, use the completed rows as a guide to help you fill in the blanks. Draw arrows to show the factors that are being pulled out or distributed. So on the left side over here, we have distribution. On the right side, we're pulling out, right? We're pulling numbers out. So I'm going to continue with the blue pen. So X is actually being distributed to both the 3 and the 2. So now we have 3x plus 2x. Goodness, this is going to kill me today. Okay. And then here I can pull an x out of both of these. These are common, right? Common factors. So I'm pulling x out. I'm left with 2 plus 3 with an x on the side. Just like that. There are a ton of these, and so I'm only going to do the first few because we did these ones in class. You should have it written in your notebook already. If you have not written this in your notebook already, actually, you know what I might do is I might just take a picture of this page instead of doing it right here. Post a picture of the page in the content library so that you guys have access to it. I just don't want to bore you and do 30 minutes of distributing properties. Okay, so actually, I'm going to skip this part. I hope that makes sense to you. If I chose any of these, like this number 7, I would be distributing x here and here. Right? So I have 2x. Nope, that's not true. Sorry, 7x minus 2x. And then over here, I would be pulling x out. And I would have x times 7 minus 2. A question for you. Can I take this x and actually rewrite it over here so that it looks like equal sign? Tell me if this is equal or not. 7 minus 2 with an x on this side. Are those equivalent? The correct answer is yes, those are equivalent. 7 minus 2 times x is the same thing as x times 7 minus 2, right? I'm going to do one more for you. Down here where it's a lot of letters. Number 12, let's look at number 12 together. So number 12 is x times y minus 4. And I can distribute the x into the y and to the 4, right? So now I have xy minus x4. Or we wouldn't write it like that, right? We would write 4x. And then I could, so this looks like this, right? Those are the same. Okay. Same deal, I'm gonna pull an x out, pull this x out, and I can do that because they're products. I'm left with y minus 4. Sorry, that was supposed to be circling. minus 4 times x. Okay, that will be on your homework tonight. And if you have questions, I really need you to tune into that Zoom tomorrow at 1 and ask me those questions so we can do some of those together. Okay. Moving on. So sometimes you can apply the distributive property to part of an expression to write an expression or an equivalent expression. So for example, in example 1, we have 3 plus 2 times a plus b, which is equal to 3 plus 2a plus 2b. And we can model that with the model down below, where it says 3 times a plus b, a plus b, right? So 3 plus a plus b plus b. So right here, we're distributing. This was the distributing part. This was the rearranging part, or the commutative part. So first, we broke it apart, and we distributed the numbers or the values. And then here, we just rearranged to make it look better. Now all of my a's are together, all of my b's are together, and all of my known values are together. And now I can just simplify, right? So 3 plus 2 times a plus b is the same thing as 3 plus 2a plus 2b. Awesome. So for example number 2, same deal. We have, we're distributing first, right? We're going to take this a out. Whoops, that's not what I want to do. We get this a out here. And yeah, so we commutatively distributed by distributing here and then just rearranging them. Okay, good. So number 14, look at example 1, use the diagram to help you find a third expression that is equivalent to. So it wants you to find yet another one. And so instead of 3 plus 2a plus 2b, we could write, well, there's a couple. And in class, we decided that we could do 3 plus a plus b plus b, right? That is equivalent. Another one that we could do that's different than this one up here, I'm going to make this one in blue, is 3 plus 2b plus 2a. So here I just flipped this. Flipped this one and this one. Right. Okay. Apply the distributive property to part of each expression to write an equivalent expression. Model the equivalent expressions with diagrams. Okay. So this one, I'm going to start with my arrows, because that's going to help me with commutative property, right? 3 is going to be distributed to both C and D. So now I have 3C, oh my gosh, plus 3D plus 6, right? And I can model that over here. I'm just going to write this tape diagram, and I have 3 C's, right? Okay, so I have 3 C's, 1, 2, 3. I have 3 D's, 1, 2, 3. And then I have 6 known values. 2, 3, 4, 5. I'm going to add one over here. So these are known values, and we're just going to represent them with dots. Okay. Same thing over here. I'm going to pull out. I'm going to pull out a 2 from here, right? So now I have 7 plus 2 times E plus F. You should have that written down in your notebook already. I'm going to do another black one over here and add color later. Okay, so here I'm seeing that I have 7 known values, and I'm going to represent that with dots, right? At 1, 2, 3, 4, 5, 6, 7. Okay. And then I have 2 E's and 2 F's. Two E's, 2 F's. And I made this too big. So I'm just going to get rid of that real quick. Cool. All right. So there's my visual representations, 7 plus 2E plus 2F, and 3C plus 3D plus 6 unknown values. We have one more page. This is at the bottom of page 198. And this is when we get into greatest common factor, which you guys should have been practicing on Prodigy. So you should be excellent at this still by now. So tell whether the expressions are equivalent. This is looking for a yes or a no. And so real quick, number 17, 5 plus 3 times A plus B, and 5 plus 3A plus B. No, these are not equivalent. Oh, I don't want to use a highlighter right now. No, these are not equivalent because this person, whoever wrote this, did not distribute their 3 to their B. This is actually 5 plus 3A plus B, 3B. Number 18, 5 plus 3A plus B and 5 plus 3A plus 3B. Yes, that is correct. Okay, 4 plus 2C plus 1 and 4. No, I already know that that's not going to work because there was no distribution. All they did was change where the parentheses were, and that doesn't work. Number 24 plus 2C plus 1 and 4 plus 2C plus 1. Let me think. Looks good to me. The only thing that they did was they changed where the parentheses were, but it doesn't affect the outcome of the solution. So yes, these are equivalent. Number 21, yes, those are, because these were properly distributed. We took 3 and 4 and combined those, and we were left with 2 and 7, because 3 and 4 is 7. Number 22 is no, because 3 plus 2F plus 4, there is no, I mean, there are only 2 F's. So it makes it really strange that they would put 5 F's over here when there wasn't to start with. We cannot just mass produce those. They don't come out of nowhere. Okay. Make sure I'm still recording here. Greatest common factors, we talked about this, and these can be really, really tricky and really difficult. We've worked a lot with least common factor in 4th and 5th grade, and now I'm asking you to do the greatest common factor so that you can do all of that backwards. So for example, they've written out all of the factors for 48, 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. And then they did all of the common factors for 32, which is 1, 2, 4, 8, 16, and 32. Well, we notice that the greatest common one is this 16. 16 is the greatest number that is a factor of both numbers. So 16 is the GCF of 48 and 32. And so we wanted to find the greatest common factors for these numbers. I'm going to let you go ahead and do that. If you haven't already in your notebook, most of you should have already. We've already done this. So if you haven't, push pause, do it, and then catch up with us. If you have, let's continue. Number 23. The greatest common factor between 15 and 12 is 3. For number 24 and 36, it's 12. 21 and 26, the greatest one is only 1. 42 and 56 is 14. 27, 30 and 48 is 6. And this one's tricky, 30, 45, and 75. I know it's probably going to end in a 5 because of they're all divisible by 5. And I noticed that they are all divisible by, or they are all factors of 15. So now we're going to combine what we know about the greatest common factors and the distributive property. And this is a huge jump, so bear with me. Please write down questions so that I can answer them for you tomorrow on Zoom. Okay. So write each sum or difference as a product using the distributive property to pull out the greatest common factor. Show all your steps. Okay, so for 63, we took out 9 and 7. I'm just going to color code these real quick. For 63, we took out 9 and 7. And for 54, we took out 9 and 6. Now, I can take out, using the distributive property, I'm going to take out a 9, right? What we practiced up here in the first step. All the way up here. Yep. We're pulling out, we're putting in, all that good stuff. And now what I'm going to pull out is a 9. And then what I'm left with is 7 plus 6. Do you see that? If you don't see that, if you don't understand that, let's go through 30, 31, and 32, and then I need you to ask questions. It's really, really, really important for you to ask me questions. There are lots of different tools that we can use for doing this, and it's really important that you know how to do this moving forward because things are about to get a little more complicated than just using simple numbers. Okay, 63 and 56. I can break 63 into 7 and 9. And I can break 56 into 7 and 8. And then I can pull these 7s out, right? And multiply them by the sum, or the difference, I'm sorry, the difference of 9 and 8. Just like that. Which, again, you should have already written in your journal. This should be review. We've done this lesson before. Okay, number 31, I'm going to pull 7 and x. These are the products, right? I can break 7 into 7 and 7 times x. And then 35 into 7 and 5, because that's a greatest common factor between 7x and 35. The greatest common factor between 7x and 35 is 7. And so I'm going to pull these 7s out, and I'm left with x plus 5. Again, down here, I'm going to do, well, I don't know why my pen's not working. So 24 in x, I can do 6 times 4x. And here I can do 6 times 3y, right? So now I have, I'm going to rewrite it up here, 6, 4x plus 6 times 3y. I can pull 6's out. And I'm left with 4x plus 3y. Yeah. Okay, that's pretty much it. Tomorrow will be a homework day and a Zoom day. And then Wednesday you'll have lesson 9. I will teach you lesson 9 again. It looks like we've already done that one as well, but it's going to be tricky to get back into it. And then we'll have a quiz on Friday, and then next week we will start on lesson 10. So have a great day. Let me see.